Alright, tonight we're going to talk about the tangent line, and this is one of the ones where you're going to need to know. I asked you on your calculus readiness, can you find point slope? A lot of you guys mostly put it in y equals mx plus b form. That's not quite what I was looking for. I was looking more for point slope, which is located down here. I gave it to you. You'll be using this a lot. It's a very easy equation to use. I know you haven't used it much in the past, but in calculus it's a lot easier than using slope-intercept. It's to find the equation of a tangent line to a function. Again, a tangent line looks something like this. So here's my graph. I have some sort of curve. And so I'm looking at this point right here, and if I was going to hit that point once, what is the equation of that blue line? And so given some sort of, they would give you, they're going to give you that x-coordinate. They want you to be able to use that x-coordinate to find your y-coordinate. So they give you the x, they want you to find the y, and be able to find the slope of that blue line. And so you may, a lot of times you're going to have to find the y value of the point. You do that just by plugging into the original function. So you're going to plug it into whatever the, whatever f of x is, which is our curve right here. Whatever they give you, you're just going to plug in that x coordinate, and it'll spit out the y coordinates. You find your derivative just by using your derivative rules, and then evaluate it at the given point. So remember, we talked about the instantaneous rate of change. This is where you're going to actually find the m. That's doing the instantaneous rate of change. Sometimes later on we're going to talk about what happens when we have x's and y's mixed into into the equation. That's going to be probably deal with that in November, I believe. But at this time you're not going to need to plug in a y value, but there's going to be a situation later on which I will show you how to find the tangent line, where if we have an unusual function where x and y are mixed together, such as x squared times y plus y squared is equal to 5. Okay, it's not too bad, but there's going to be times, just I wanted to preview ahead, that you will need to plug in a y, but not today. You don't need to worry about that today. And again, remember, you're going to be using that point slope. It's a lot easier if you have an x value and y value that you can just plug in. So the way it works is y minus the y value that you previously found above, and then m, this is going to be your instantaneous rate of change. What is that value? And then you're going to do x minus the x coordinate. Whoops, that's not the one I wanted to use. X minus the x coordinate that was given to you. So let's go ahead and hop in through see several examples. So let f be the function divided by f of x is equal to 4x to the third minus 5x plus 3. Find the equation of the tangent line to the graph of f at the point where x is equal to -1. So first thing I want you to notice is they did not give me the y coordinate. So I need a point and I need a slope. So first, for my point, they gave me x, or excuse me, let me go and write -1, but I don't know the y coordinates. So the first thing I need to do is, what is f of -1? And so if I plug it in, it'll be 4 times -1 to the third minus 5 times -1 plus 3, which is going to give me -4 plus 5 plus 3, which is equal to 4. So my y coordinate in this case is 4. The next thing I need to do is find the derivative. So what's f prime of x? Well, that'll be 4 times 3 is 12. Subtract 1 is squared, minus 5. And so now I can find the instantaneous rate of change by plugging in my x coordinate. So f prime of -1 is 12 times -1 squared minus 5. And so that's equal to 12 minus 5, which is equal to 7. Notice, if I was going to label this in algebra 1, we would have called this m. And so my tangent line, I'm going to use y minus my y coordinate is equal to my m times x minus my x-coordinate. And so since it's a negative, negative times a negative is a positive, so I'm going to go ahead and put plus 1. And that is the equation of my tangent line. You do not need to write it into standard form. You don't need to write in slope-intercept form. You can just leave it in point-slope form. And so in this case, it's actually preferred. Number 2, if the line tangent to the graph of the function f at the point 1, 7 passes through another point, -2, -1, or -2, -2, then find what is f prime of 1. Again, prime means we're talking about slope, so we want to know what is the slope. And notice that the tangent line is going through these 2 points. So if I was going to graph this, just to give you an idea, let's go ahead and get our coordinates. And so I need to go up to at least 7, 1, 2, 3, 4, 5, 6, 7. And I was going to graph these points. So the first point is at 1, 7. The other point is located at -2, -2. And I have a line that passes through these 2 points. And so they want to know what's if f prime of 1 is the slope, so if f prime of 1 equals the slope, what they want us to find is slope. So let's find our m. So m is equal to, let's do 7 minus -2, so 7 plus 2, divided by 1 plus negative, or minus a -2, which would be plus 2. Well, that's 9 over 3, which is equal to 3. So that was our m. And so let's go ahead and answer in terms of the question. So f prime of 1, which is my slope, is going to be equal to 3.